Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting tonight will be the DC to DC converter that I assembled. Okay, this is the DC to DC converter. The serial number of this one is SC08CV. If you we try to bring out the data sheet of this DC to DC converter. It's a constant voltage, constant current DC to DC converter. This is rated 10 amperes, and the voltage specification of this one is the input voltage. The range is from 5 volts to 30 volts, so we could input any voltage between 5 and 30 volts. For the output voltage, the range is actually 1.25 to 30 volts. So, depending on the input voltage, we could bring out an output voltage with the range 1.25 to 30 volts. Later on, I will try to specify the voltage input of this one. Okay, what I did, guys, is that originally I got a power supply in which I assembled the rectifier portion plus the voltage regulator portion. This transistor head or voltage regulator is actually a 12-volt regulator. And the rectifier that I use is actually it's a 2 diode, so it should be a full wave rectifier. So the one coming from this one is alternating current. It will be injected here. It will be rectified by these 2 diodes here. And in the configuration full wave, and the output of that full wave is injected to this 12-volt regulator here. This is a 12-volt regulator. So what I did, guys, is that on the output of the regulator, I connected 2 electrolytic capacitors with big capacity. These are big, right? These 2 here are in parallel. So on the output of the 12-volt regulator, these 2 capacitors are actually in parallel. And that will be the one helping the voltage requirement of any load connected to the output terminal. But the one I'm doing tonight is that the load on the 12-volt regulator is actually a DC to DC converter. Okay, so for this one now, I will be injecting, since the output of this one is 12 volts, okay, that will be the one injected over here on the input of the DC to DC converter. This is 12 volts, okay. So if we try to inject a voltage 12 volt on the DC to DC converter, since this converter is actually a buck boost, meaning it could decrease the input voltage to a certain value, or it could increase that input voltage to a certain value. That's why this converter here is a combination of a buck and boost converter, meaning it could decrease the value of the input voltage, it could increase the value of the input voltage. That depends on what you call this, what load you will be using at the terminals of the DC to DC converter. I set this one already. Hold on. I will be measuring the voltage output of this DC to DC converter. Actually, I initially decrease already the voltage of this one to 6.6 because the load I am using will be needing a 6 volts. Okay, so I will be connecting my multitester to measure the DC voltage at the output. You see it, guys? Okay. This is the multitester set to measure DC voltage, and I would like to measure the voltage output of this DC to DC converter. A while ago, I do it in advance. Like what I said, the input voltage on this one is 12 volts, and I adjusted already the output to be 6.6 by using this terminal here. Hold on. I'm using my this one here, the what you call this, the rheostat for the constant voltage. This is for the constant current. If you would like to decrease the voltage output of the converter, just rotate this one clockwise. Okay? Since we input the voltage here of 12 volts, okay, by rotating this CB here or rheostat here for a constant voltage, we could decrease the value of the voltage of the output. If you would like to increase, just turn the other way around. It should be the counterclockwise. Like what I said, I did already adjust this one, okay, by rotating this one here. Okay, I rotate that one already. I inputted 12 volts here. For me to bring out a 12 volts, 6 volts output, I rotate this rheostat here, the lower portion. Okay, clockwise. So a while ago, I did that already, and to show you that the output voltage is 6 volts. Hold on. I plug in already the. Oh, not yet. I plug in, but it's not switched on. Okay, I'll switch on. Okay, I plug in the AC transformer. Okay, that AC voltage will be rectified by this full wave rectifier here, and the voltage output of this rectifier will be injected to the 12 volt regulator. Okay, and at the output of the 12 volt regulator, I connected two big electrolytic capacitors in parallel. Okay, so when a load needed so much juice, this electrolytic capacitor will help supply the needed current for that load. And I place also an LED indicator here, meaning if you try to measure the voltage across this is 12 volts. 12.6 something like that, but because this is a 12 volt regulator, and this 12 volts here or 12.6 is injected here at the DC to DC converter, and to reduce or decrease the voltage output of this one, like what I said, I tried rotating this one here, this terminal here. Okay, and right now, since I rotated it already, the voltage output is 6.6. Okay, I'll try to rotate this one so you can see it. I'll try to increase this one. I better plug in my. Okay, my light, so I could see the I will try to increase the voltage. So you believe in me that by rotating this one, we could actually increase or decrease the voltage output of this DC to DC converter. Uh, I was able to rotate a little bit. The voltage is now 7.13. So you believe in me that by rotating that knob there, we could actually increase or decrease the voltage output of this converter. Okay, I will bring it back to 6.6 because I would like to show you that this DC to DC converter could, what do you call this, okay, it's back to 6.66. You see it, guys? So by rotating one way, we could increase the output voltage, and by rotating the other way, we could decrease the voltage. Right now, I place it at 6.66 volts because I would like to show you that I will be connecting a load here, and let us see if this DC to DC converter could deliver the required juice. Okay. I will be adding another extension here. This one here with the red is the plus. Okay. This black here without the zip tie red is actually the ground. Okay. This is our DC to DC converter. This is the regulator and rectifier portion. And this will now be the output of the DC to DC converter. These two extension, I will be using that one to connect my load. Okay, my load is still the same. Uh, this is an AM FM receiver in which I remove already the AC power supply because I bring out the two terminals from the battery. The red one is for the plus, the black one is for the minus. And I put in parallel a small capacitor here to, what you call this, to eliminate buzzing sound. Okay, so to energize or to operate this AM FM receiver, okay, we must have to inject a voltage. So I will be connecting the plus here. Okay, and I will be connecting the white to the minus.
The idea of a public bank for Los Angeles surfaced a long time ago and then waned. It's resurfaced now, championed largely by Councilmember Hugo Soto Martinez. He believes it would save the city a lot of
works,
money.
guys.
I'm Craig Figner, KNX News 97.1 FM.
Remember cameras and flip phones? They're making a comeback.
More young people have had enough.
I just spent the last 2 hours setting up a flip phone for my son.
Parents like that dad are helping teenagers who feel they're losing control to screens.
He said that smartphones were making him sad. His Instagram feed, his TikTok, he was losing time.
Working,
and what
guys.
he really wanted was music.
So I will be flipping.
They're dialing it back to the early 2000s
That's
with
our load.
digital cameras.
So all you really have to do is just aim
It's
the camera, press the
being
button, and
powered
it'll
up
automatically focus.
by this DC to DC
Younger
converter.
fans like Taylor
But prior
Swift
to
are selling
that,
CDs,
I
vinyl
assembled
records, and
a
cassettes to
what you call
supplement
this
streaming. Deborah Rodriguez, CBS News.
regulator and what you call this the regulator portion. Okay, because the one coming from this one is AC. We must have to rectify it. I use 2 diodes, so this is full wave. The output is actually injected to this 12-volt regulator here. And the output of the 12-volt regulator, I connected 2 big electrolytic capacitors in parallel. Okay, so these 2 electrolytic will help deliver the needed current for the load, if it needed the current, like an amplifier maybe. And the output of this 12-volt regulator is injected to this DC to DC converter. The serial number of this DC to DC converter is SC08CB. This is a constant voltage, constant current converter. This converter could decrease or increase the input voltage depending on what you will be using as a load. Right now, I inputted 12 volts here, and I want to use the output to power up this AM/FM receiver because this receiver here needed 6 volts. So I set the output a while ago. I have shown you a while ago. I set it to 6.66, and I connected the 2 terminals at the back of the receiver. Okay, that's the 2 terminals. I removed the AC cord already. I don't want to use the AC cord. Okay, so I will be using this DC to DC converter to power up this AM/FM receiver. Again, I will try to increase the volume.
The share of some well-known companies took a hit.
Okay.
Sudden flare-up in trade tensions with China.
It works.
Stocks careening
It
lower,
works.
led by big tech names,
Right?
including
It works.
Nvidia, Apple, and Amazon.
CBS News
That's it,
business
guys.
analyst Jill Schlesinger.
Today's sell-off was about as bad as we...
This is a DC to DC converter powering up this AM/FM receiver in combination with the tape player. And as you can see it, even if we try to increase the volume, the sound will not be having an interference, because if the current is not so much, there will be something like a buzzing sound, you know. Okay, I will try to increase again the volume.
Capitol Hill.
More than 1 million plus troops are expected to get paid, but
See,
in this
guys?
instance, they will not get that paycheck. That has been a big concern here on Capitol Hill, where there has been a bipartisan push to pay troops at the very least. Standalone vote.
That's it, guys. This is a topic on DC to DC converter to power up any gadget which needed a regulated power supply. Good evening from Los Angeles. This is Professor David J. De Los Reyes.